a reference sheet for this is this triangle right here.
Okay.
So the more difficult problem that you might see, and I'm going to draw the reference triangle on the left here. X root 2 is when I give you the hypotenuse, but let's say I tell you the hypotenuse is 20. So it's not as simple as just reading that number there. So the strategy here is you set the known side, which in your case is 20, equal to the reference side. And the reference side means the same side on the reference triangle. So you set 20 equal to x root 2, and then you solve for x. So to solve for x here, you divide by the square root of 2 on both sides of the equation. And this is correct, but it is not simplified. You do have to rationalize. So to rationalize, you multiply the top and the bottom by the square root. So I'm just going to grab a different color here. Square root of 2, square root of 2. So on the top, it becomes 20 square root 2. And on the bottom, it's the square root of 4 or 2. So it's 20 square root 2 over 2, which equals 10 square root 2. And that's the value of x. So the question you might see in your geometry, your algebra 2 trig is it would say find the unknown sides, and you would know that this is 10 root 2, and this is also 10 root 2. Okay, so what I'm gonna do here is I'm gonna draw the reference triangle here again for you, and I'm gonna ask you to try an example problem here. So let's say that this side right here, the hypotenuse is, I don't know, we'll go 40. Will you solve for the value of x for one of the legs, please? How are you doing on this one?
I'm just a bit confused.
Okay, so you set the known side. Which is the known side?
40.
40. You set the known side equal to the reference side. What is the reference side?
X squared.
Yes. So I mean, this is the reference triangle on the left, and we're going to do this for a lot of the problems we're going to look at today. So this is going to be a continuing theme. And now you solve for x. So you divide by the square root of 2. Just like in the last problem, you have to rationalize. So you rationalize by multiplying the top and bottom by the square root of 2. So it becomes 40 square root 2 over square root 4. The square root of 4 is 2. So we can write 40 square root 2 divided by 2. 40 divided by 2 is 20. 20 square root 2 is equal to x.
Okay.
Okay. So rather than give you an exactly the same problem here, I want to remind you that the triangle could be oriented really, in any manner. So I could, for example, give you a square and put the diagonal here. And I could tell you that the diagonal is 12. And I want the side lengths. Okay, and again, I'm not trying to be confusing here, but I don't want to just give you the same problem with the same numbers, just different numbers here. I want you to see though that in a square, the side lengths are the same, just like in a 45, 90 triangle. So you're essentially setting this 12 equal to x root 2 again. Then the question would say, like, what is the length of the side? Okay, but you're going to do the same thing. You're going to set this 12 equal to x root 2 and solve for x. So can you try that for me, please?
Okay. Is it 6 square root 2?
It is. X is 6 square root 2. Perfect. Okay. Now, let me show you a couple examples where I don't give you such nice numbers, but let's say I give you a right triangle again, 45, 45, 90, but I tell you that the hypotenuse is 13. So you set the 13 equal to x root 2, divide both sides by root 2. Okay, and then again, you do have to rationalize. So this becomes 13 root 2 over 2. Now these don't divide. So this is okay. It's okay to have a fraction.
Okay.
And that's kind of the only oddity that you might see there. But here's another possibility. Another possibility is I tell you that the hypotenuse is the square root of 8. So again, since it's a 45, 45, 90 triangle, you would set square root of 8 equal to x root 2. Divide both sides by root 2. Now on the left here, do you have any idea how to simplify this?
No.
So there's a property of exponents. If you have square root of a over the square root of b, you can do the following. You can actually divide first and then take the square root. So for example here, this would be the square root of 8 divided by 2. 8 divided by 2 is 4. Square root of 4 is 2.
Okay.
But it's the same initial step. And that's what I want you to see, that it's the same initial step. You set the known side, which was the square root of 8, equal to the reference side. And you're going to do that in all the problems we're going to do today.
Okay.
So let me have you try one here. Let's say I tell you that the hypotenuse is the square root of 18, and I want you to solve for x. So I want you to do the same thing that we've been doing in all the other problems. I want you to set square root of 18 equal to square root to x squared 2.
Is 3?
So your answer is x equals 3.
Yes.
Okay, so we're going to take a look at that by going opposite. So let's say this is 3 and then this is 3. The other way to do it, okay, is to take this length, right, and multiply it by the square root of 2. So the hypotenuse is 3 square root 2. And you are correct. I'm just wanted to show you this going backwards here. That 3 squared plus 3 squared, this is the Pythagorean theorem, equals c squared equals 3 square root 2 squared. This is 9 plus 9. This is 9 times 2, 18 equals 18. So it is correct.
Okay.
Very good. Okay, now it doesn't always work out as a nice number, unfortunately. You know, a friendly number, one that, you know, we like seeing. Let's say the hypotenuse is square root of 10. So again, we set the known side, square root of 10, equal to the reference side, x square root 2. You divide square root of 2 on both sides. And as I mentioned in the previous problems, you can actually divide before you take the square root. And 10 divided by 2 is 5. But the square root of 5 is not friendly. We don't know what it is, okay? But this is your final answer. And that's an answer you might see on a multiple choice. You would not see it on the free response because there wouldn't be a way to enter that. Unless you had a calculator, I suppose. So just as an aside here, before we move on to another problem, which two numbers is the square root of 5 between? And I'll give you some choices here. Letter A, 2 to 3, letter B, 3 to 4, and C, 5 to 6. Do you have any idea how to do this problem without a calculator?
No.
So if we go to a number line, and this is probably going to help you figure this out pretty quickly, I'm going to put the whole number on the top, and then its square root equivalent on the bottom. 1 is the square root of 1. 2, though, 2 is the square root of 4. And then 3 is the square root of 9. Where does square root of 5 fall? Does it fall between here, this position, or further out?
It falls between 2 and 3.
Between 2 and 3. Very good. Okay, so let's go back to our triangle problems. Let's solve a couple more here. Let's say that the hypotenuse this time is the, let's say this time, sorry, losing my mind here a little bit. Let's go square root of 26. Can you find the value of x for me, please?
Is it 13?
Just 13 like this? Like if this were letter A, would you mark your answer letter A? I'm kind of hinting that there's something missing.
Is it the square root of 13?
Yes, it is the square root of
Okay.
13. Okay, now which two numbers does the square root of 13 fall between? And if you need to, make a number line or use your notes, but could you give me the two whole numbers that the square root of 13 falls between?
Um, 3, 4.
Yes, so 3 is the square root of 9, 4 is the square root of 16. And this is how they work around sometimes these problems where you don't have a calculator, they just ask you, well, which is it between? Okay, so then the only other type of 45, 45, 90 that you might see is, let's say I tell you that the leg here is the square root of 45, and I want the hypotenuse. So the hypotenuse, you take a leg and you multiply by the square root of 2. So you have the square root of 45 times the square root of 2. This property says you can multiply before you take the square root. So in this case, it would be the square root of 90. But this is not reduced. So the question I have for you is, do you remember how to reduce roots? And the hint is that you use prime numbers. Do you have any idea how to continue this problem? How to reduce the square root of 90?
Not really.
Okay. What is the smallest prime number that you know?
Um,
So this is sometimes a question you'll see, is 1 a prime number? And the answer is no. You might think, well, why isn't it? But 2 is. Is 2 a prime number? Yes, it is.
mhm.
The reason is that it has to be divisible by both 1 and another number. So the reason 2 is because it's divisible by both 1 and 2, but only those 2. So your list of prime numbers, and you do want to know a small list here of them. 2, 3, 5. We skip 4 because it's divisible by 2. 7, 11, and you don't really probably need to go much past this. Okay, so the way you reduce a root, so we're kind of like, it's like we've been talking about over here on the left, we've been talking about how to work these triangle problems, but there's all these other skills, and we're working on those now. And the skill we're going to work on right now is called reducing roots, or how to reduce roots. So the square root of 90, you take your smallest prime number and you ask yourself, is 90 divisible by 2? And it is. 2 times 45. Is 45 divisible by 2? No, but it is divisible by 3. 3 is a prime number, so 3 and 15. Then you try 3 again. 3 and 5. So these are called, these numbers on the outside, these are called your leaves. I know we don't have a lot of leaves in Arizona, but these are considered your leaves. And it's branching or forking, if you will. Okay. So when you're reducing a root, you're looking for pairs. Do you see how there's a pair here?
Mhm.
So for each pair, you can bring a number out of the root. So this square root of 90, you bring the 3 out, and what's left over? Well, 2 is left over and 5 is left over. You only look on the leaves. So the 2 and the
Okay.
5 are left over. They're the leaves, and they go back inside here. So your final answer is 3 square root 10.
Okay.
But it all starts from knowing your primes. Okay. So let's have you try one here. See if you can try one on your own. I'd like you to reduce the square root of 12, please. And you're going to start with 2. So give that a try. I'll check back with you in a minute or two. How are you doing on this one?
I got 2 square root 3.
That sounds perfect. So for each pair, you bring one out, 2 square root 3. Good. Okay. Let's try one that's just slightly more difficult here. Let's go, let's have you try the square root of 60. And I'll check back with you in a moment. Okay, how are you doing on this one?
I got 2 square root 15.
Okay, and that is correct. Very good. Okay, fantastic. Okay, so let's move our attention to 30, 60, 90 triangles. And these are a little bit different. They're more involved. There's what's referred to as a short leg, the smaller leg, the long leg, and the hypotenuse. And again, like there's no problem on the SAT where they're just going to ask you straight up to find one of the sides, but they're going to ask you in another context to use this information. So that's why you've got to be so solid at this skill. That way, when you see the problem, you can quickly work through this. So the reference triangle, the short leg is x, the hypotenuse is 2x, and the long leg is x square root 3. And I'm sure you've seen this before. Maybe it's been a while, but you can definitely, do this problem, do these types of problems with a little bit of review. So let's actually, let me grab the reference triangle here and let's see if we can do an example here. These are it's more like, these are more like worksheet questions, but they're good for review. So let's say I tell you that this is 10. What is B and what is C? Can you tell me those values?
I don't remember how to do this.
Okay, so just looking at the equation, you set the known side equal, your known side is 10 to the reference side x. So in your problem here, x is 10. X is 10. C is really 2x. What is x? X is 10. So we do 20. What is B? What is B? B is x squared 3. Well, what's the value of x? X is 10. So you take this known side and you morph it into the other ones.
Okay.
When it's given. This is the easiest case where they give you the short leg. Okay. So again, I'm gonna just, it won't help if I give you exactly the same thing, but I'll just vary it slightly. The reference triangle could be like this, where this is the short leg. It's always drawn as the smallest. 2x, x root 3. And I could give you a triangle now where the orientation is just slightly different. But let's say that the short leg is 15. Can you find B and C for me, please? How are you doing on this one?
I think I got it.
Okay, what is the value of C?
I said 30.
Okay, because you double that side, perfect. And how about B?
15 square root 3.
Very good. Okay, let's try another one here. Do you have this reference triangle down, or do you need me to draw it each time?
I wrote it down.
Okay. All right. So let's say this time I'm going to give you the hypotenuse. I'm going to tell you the hypotenuse is 12, and I want A and B. And I'm not being deceptive here. This is the short leg, and this is the long leg. I am going to draw the reference triangle again, because if you ever are unsure what to do, you set the known side, your known side, equal to the reference side, and that will allow you to solve for x.
Okay.
So see if you can find, in this case, A and B for me, please. Do you have any answers to share yet?
Yes.
What is the value of B?
I just said 12.
So x, if you set 12 equal to 2x, that's the known equal to the reference, and you divide by 2, x is 6. X is the short leg. So in your problem, B is the short leg, and B is the value of 6. And notice that if you double this, or go the other way, you take a half of it, you get back to the, you can go back and forth between them. To find A, to find the long leg. And so sometimes it's easier to do this in words. So the long leg is the short leg times the square root of 3. The hypotenuse is the short leg times 2. Alternatively, you could say the short leg is the hypotenuse divided by 2. Maybe these will be more helpful for you. Because when you go
Okay.
back and look at this picture, you say, oh, I've got the hypotenuse. To find the short leg, I take half of it. Or if you're given the short leg, you double it to get the hypotenuse. And then the long leg is always the short leg times the square root of 3.
Okay.
Okay, so let's try another problem here. Let's say I tell you that the hypotenuse is 18. And another way that they can indicate that this is a 30, 60, 90 is they can put a 30 there. That means that this right here is the short leg. So I want you to find A and B for me, please. A is the short leg, B is the long leg. Give that a try, please. Do you have a value for A and B?
Yes.
Okay, what is the value of A?
9.
9, and B?
9 square root 3.
Perfect. Okay. And the Pythagorean theorem does still hold here. It's just that it's doing it the long way. If you take 9 squared, 9 square root 3 square it equals 18 squared. This is 81. This is 81 times 3, so 243. And then this is 324, and they do line up. Okay, so let's do a couple more problems here. I've been kind of doing there's case, I call them cases. Case 1 is I give the short leg. And we did a bunch of problems like that. And then we just did case 2 where I give you the long leg, I'm sorry, the hypotenuse. And those are significantly easier than when I give you case 3, which is the long leg. And you'll see why here shortly. So let's say I tell you that the long leg of this thing is 12. Then I want you to find A and C. So the reference triangle, which if we were doing this in a traditional classroom, I would ask the students to always draw the reference triangle. It does help to remember it. But then from here, you always set the known side, which is 12, equal to the reference side. 12 equals x square root 3. And then you divide both sides by square root 3. Now, just like when we were doing the 45, 45, 90, you rationalize by multiplying the top and the bottom by the root. In math, we just don't want a root on the bottom. So it's 12 square root 3 over the square root of 9, which is 3. So the 12 and the 3 divide, making 4 square root 3 equals x. Now, if I go back to the original problem here, that x is your short leg. So that means that this is 4 square root 3. How do you find the hypotenuse from the short leg? Julia, do you remember what we said in words? What do we do to this number right here?
The hypotenuse is the short leg times 2.
Times 2. And so sometimes students are like, well, which number do I double? It's the outside number. So this becomes 8 square root 3. So you double this number in front, or you take half of that number in front there. All right, so I do have some practice worksheets on 45, 45, 90, and 30, 60, 90. Let me just pull them up here. Yeah, so what I'm gonna do is I'm gonna put those in the email that I send you. Just links to those. I would recommend working those out if you've got time. It's a hugely important skill that you see on the SAT, ACT, and you just gotta get fast at it. So that does take us to the end of our lesson for today. Do you know if for next week you want to meet on Monday, Wednesday, or Tuesday, Thursday? Do you have a preference?
I think if we could do Tuesday, Thursday, I think that would be a little easier.
Sure. And is the 1 p.m. time good for you, or would you prefer 2 p.m. or 3 p.m.?
I think 1 p.m. is good.
Excellent. All right. I will send you the notes in the screen recording here shortly, and I'll see you next week, and I'll have an updated practice for the week for you as well.
Okay, thank you.
You're welcome. Bye now.
Bye.